What we have here is a setup person loading up all of their tools for the day. But hold on a second, wait. Mistakes have been made. This newbie setup guy has made some mistakes that are going to cause us to break tools, to run parts out of position, and maybe even jam up their tool changer. But to avoid these kind of newbie mistakes, okay, boomer, yeah, I know, that can cause us problems. That's why we're going to look at how to avoid those mistakes in this Haas tip of the day. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up here. Okay, boomer. I am excited about today's tip of the day because it's such a common topic, right? Anyone who's around a Haas mill loads tools. Every setup guy, programmer, and some operators are loading tools. But what we saw earlier with that unnamed setup guy putting the tools in was actually pretty bad. Some bad things were happening. Number one, he was loading up a large tool and he had not yet designated it as a large tool on the pocket tool table. If you've got two large tools next to each other in the carousel, they might bump into each other and jam things up. And then you have to go through an entire recovery process. So we've made an entire video about this. We'll link to it in the description. So we're not going to talk about that anymore in this video. What we are going to talk about is boring bars. Boring bars are fantastic. If you want to get just perfect positioned holes, this is the way to do it. The reason that they position so well, that they put the holes right where you want them, is because this type of tool is not influenced as much as an end mill or a drill or even a ream, because they have a single insert. It's called a single point tool. It has the same load as it comes around, right? For the most part. Hold on one second. This will make more sense if I have some example parts. Okay, I've got some parts here. So for a normal boring operation, our tool is going to come into the spindle, start rotating, it's going to feed down, and then what's going to happen is at the bottom of the hole, it's going to orient itself, and it's going to face most likely to the left. If the boring head at the bottom of the hole is facing to the left, it's then going to stop and it's going to retract by a certain distance. That distance is defined by the Q value on our G76 line, and then it's going to retract up. Now, why do we do this? We could just use a reaming cycle, which means it feeds down and it feeds up, right? Just feed down, feed up. We're not going to use that typically with our finished boring cycles. Giving it that kind of spring pass, it might leave a beautiful finish on the way down, and then as it feeds back up, it's not really grabbing the material, it's just kind of rubbing up against it, and it'll give you a crummy surface finish, and weird things happen. So we want to engage in the cut on the way down, retract, and then get out of dodge. This is where things can go really, really badly though. What if it retracts in the wrong direction? So which direction is normal? This is defined by setting 27 on the Haas control. Setting 27 says G76, G77, shift direction. And by default, from the factory, it's always going to move in the X positive direction by a Q value amount. And this is all described in the manual, but we're showing you a video here because sometimes a video is worth 1,000 words. So if you load up a boring bar into your Haas machine, we typically want that single insert facing to the left, facing in the X minus direction, because when the tool gets to the bottom of the hole, it's going to M19 orient, and then it's going to retract in the setting 27 X positive direction before pulling up. If you had put the boring head in the opposite direction, had it facing to the right, X positive, and then it actually retracts to the X positive direction, you can imagine what's going to happen. It's going to, at the very best, bust your insert, and at the worst, it's going to break your boring bar. This is also why we choose to use small Q values. If you had a giant boring head and you could retract by a 1/2 inch to one side or the other, don't. There's no reason to. You're just trying to get that insert off of the wall. So typically a Q 0.01, 10,000ths of an inch is plenty. That's more than enough. Now, on a boring head like this is it's actually a really cool boring tool by Seco. This is like a bulletproof tool. It's through spindle coolant, and also has these keyways in here to make sure that the tool is oriented and locked perfectly in the direction that it's at always. So we're not holding this in an ER collet, it's built into the holder. But if I load this boring tool into my spindle, it's always going to face at M19 spindle orientation. It's going to face this insert towards the operator. That's the Y minus direction. So in this case, with this boring head, we need to retract in the Y positive direction at the bottom of the hole. So how do we accomplish this? Well, right off the bat, we've got to get rid of the Q value on our G76 line. If there is a Q value on your G76 line, whether you've got anything else on there, it's going to always retract to the default setting 27 direction, which is X positive, which might break this tool if it's got a large value. So Q always supersedes an I or J value. So just using an I or a J is not good enough. You've got to get rid of the Q. With this tool, it's going to face in the Y minus direction. So we want to retract in the Y positive direction, which means we're going to use a J 0.01. A J positive 0.01, not a J minus 0.01. If we use an I value, that's going to retract along the x-axis, either negative or positive. I minus 10 thou will retract in the negative direction. I positive 10 thou will retract in the positive direction. A J value will always retract along the y-axis. J plus 10 thou will retract away from us in the y positive direction. J minus 10 thou will retract towards us in the y minus direction. So whose responsibility is it to make sure that this all happens, that it all works out? My personal opinion is that it's always a setup guy's fault. So the person who is actually putting that boring head, that boring tool into the spindle, should be responsible for making sure that that insert is facing the right direction. Again, typically on a Haas, by default, it should be facing left. But with a special tool that must be faced in a certain direction, it's the setup guy's responsibility to make sure that the program gets adjusted. Either they need to adjust it or they have to go back to the programmer to adjust it. Get rid of the Q value, add in the proper I or J value so it shifts in the correct direction. So just a really good thing to know for each and every setup guy out there. Now, along those same lines, I want to talk about our probe. Now, what does a boring bar have to do with our probe? Well, it's that M19. It's that M19 when the tool is loaded that I want to talk about. Before I load a boring bar, I go into MDI, I enter M19 and press cycle start, and I watch the spindle orient. And then I'm going to load my tool. Before I calibrate my probe for the first time, I use MDI, I press M19, I watch it orient, and then I load this tool, the probe, into the spindle, and I always load it with the Haas logo towards me, towards the operator. Now, why does this matter? Because at some point, this probe is going to be taken out of the machine. You're going to be changing the batteries, or you need an extra pot in the machine to put a tool in. And when that tool goes back in, you want to put it back in the same way you pulled it out. Because during the calibration process, a cycle is run and it decides how far is this probe off center in the X. And it puts that value into macro variable 558. And then how far is this ruby tip out of round, off center in the y-axis, and it puts that value into macro variable 559. But if after calibration you take the tool out, you rotate it and put it back in, you're going to be off by twice the amount in variables 558 and 559. If this thing was 4/10 off in the y-axis, then you rotate it, put it in backwards, and then run that probe again after calibration, it's not going to be off by 4/10. In fact, it's going to be off by 0.8 of a thou. Really, really bad. Those calibration values are there to make things better, not worse, but they'll make things worse if you don't put it back in facing the right direction. So just one more thing to consider. So we talked about loading in your face mills. Before you do that, make sure you designate large tools as large. Before you load up a boring bar, make sure you M19 and load the bar in the correct direction, and you have to check the G76 in your program at the same time. Make sure that the actual tip direction matches the programmed IJQ setting 27 values. And the same thing goes for our probes. When a probe is put in, before it's calibrated that first time, I always go Haas logo out, and then each and every time it's put in after that, make sure everyone knows to put it back in the same direction. That is it. That's it for today's tips on how to load tools. I hope you got something out of it, and we'll see you next time. Thanks for watching this Haas Tip of the Day.